So to get started with the actual rebuild of the cylinder, it's best to notate orientation of the fittings by drawing a simple picture. I would suggest representation of the body and the static end to be the end that doesn't move. To draw an illustration off of that, and the squares where the fittings sit, and then a simple line showing the direction that they're pointing will work. So for reassembly, you'll know which way to put them. So after that point, you can remove your fittings. It's important to start with a clean work surface with no contaminants so that you're not getting particles inside of the cylinders. So with the fittings removed, you can then check play on the bearings. Make sure that there's not excessive play. They should be tight and stiff to move by hand, which these are acceptable. If these were worn and you could easily rotate them and swivel them around, you'd need to replace those. And they press out, and you can press the new ones in and then retain them in with the Loctite 638. From that step, remove the end of the cylinder, crescent wrench. Sometimes we'll need to use a pair of shoes that are drilled and then cut in half to fit the body of the cylinders, which should be a supplied set with the service kit for the cylinders. So just lock that into your vise, and then you'll be able to remove the end. And this is what you'll have when you remove. So the main thing with the rebuilding of the cylinder is going to be to hone out the inside of the cylinder to remove any imperfections that are in the wall from repeated use. You want to look for grooves internally that run the length of the cylinder. Grooves that may be worn into the cylinder in a cylindrical fashion aren't quite as concerned, but the ones that run lengthwise, you need to try to remove those. So to remove those, we will start with 600 grit hone, and we'll put that in our drill press, and with a little bit of WD-40 to help with the cutting, we'll work that up and down a few times to get it clean so that we can inspect it visually. The light coat of WD-40 on your hone, which is going to be a 7/8 inch in diameter hone, and a little bit of WD on the inside of the cylinder as well. We can get it running and then feed that through just enough to clean it up so that we can visually inspect it. You use a little paper towel and clean the inside of it out, it'll be easier to see. So with some decent lighting, you should be able to look inside of it and look for any major scarves inside the cylinder that run the length of it. You'll have some generally that run from between port to port, whereas the main stroke of the cylinder. If you can see what's the worst of them and at least try to dwindle them down with the 600 grit hone.
Does that one have any?
there are some in there. Like I said, I don't think I'll be able to show you on the camera very well because it's hard to even see. You can see you have
You can almost see
glare off of it. There are some scratches that run the length of it in there that you can see. I know the camera doesn't show them very well, but once you verified that what's there, you need to try to clean that up as best as possible with the 600 grit hone. So I'll give it another maybe 6-7 passes with the hone to try to remove some of those, and then we'll inspect it again and see what we've got. And I've reduced the amount of scarfs in the cylinder by about half. So call that an acceptable amount. I'd ideally like to remove all of them, but you kind of have to pick and choose between making your cylinder wall too thin and the opening too large for the O-ring to seat again, and getting full compression out of it. So as long as we can get a tolerable amount, we'll go ahead and run with that. So now that we've went over it with the 600 grit, we'll go back over it with a piece of 1000 grit sandpaper to try to add some cross hatching into it to help the O-ring seat. So for that, I'll use a custom made piece of 7/8 inch nylon with a groove cut in it that I can put a piece of 1000 grit sandpaper into. And then we'll just put that into the cordless drill. Work that a few times to add some cross hatching in there. So what you're looking for now is that you've got cylindrical scratches into there with the 1000 grit that overlap and cross hatch each other back and forth, up and down, and that'll make it so that the O-ring will be able to seat itself. It looks like we're there, so we'll go on to the next step.